I'm sorry, but finding a center of mass is just boring. But maybe useful. So let's do this problem anyway, and power on through it. So we are finding the center of mass on a two-dimensional coordinate system of the three Stooges. And here's where all three of them are, and the number listed is their weight. So if we were going to just find a normal average, we would add up these three numbers and divide by 3. But this is more of a weighted average. So whatever coordinate they are, so this one is at 1 on the x-axis, this is at 0 on the x-axis, this is at 2 at the x-axis, that number 0, 1, or 2 would be multiplied by the weight that is at that position. And then after we've summed up the weight multiplied by this position and the weight multiplied by this position and this one, we would divide that by the total weight of all three Stooges. So let's do that. And we want both an x and a y position, but we have to do those completely separately. So let's just worry about the x position now. Let's not even care where they are on the y-axis, up or down. Alright, so the x position of the center of mass is found as follows. Let's look at 120-pound Curly down here. His position is 0, and we multiply that position by his weight, which is just going to be 0. So he doesn't really contribute. Then the next guy, 80-pound Larry up here. His x position is 1, and we multiply that position by his weight, and then we add our third Stooge. Our third guy is a 100-pound Curly, and he's at position 2, and we multiply that position by his 100 pounds. Oh, I'm sorry, the 100-pound guy was Mo. But anyway, we take the sum of those three and we divide it by the total weight of all three of them. And that's how we get a weighted average for the x position. And it looks like that's going to be 280 over 300, which is... And now that we have our x position, we can focus just on the vertical position and find our y coordinate. So here's Curly at -1 on the y-axis, multiplied by his weight. Here is, who's this guy? Oh, Larry's 80 again. Okay, so Larry's at 2. Multiply that position by his weight. And the third guy is at 0 on the y-axis, so we don't even have to worry about him. But we do include his weight in the weighted average. So it's still the sum of all three Stooges' weights on the bottom. And we do some simple math and get our y coordinate. And we just put that together, our x and y, and our position on the coordinate system for the center of mass of all three Stooges looks like this. And where is that? Let's see, 0.93 on the x, 0.13 on the y, there it is, the center of mass of all three Stooges.